Lesson 3.3, Solving Inequalities by Multiplying or Dividing. So in this lesson, there are some definitions that you will need to write. For this first slide, this is multiplying and dividing inequalities by using positive numbers. First thing I want to point out with the first bullet point is when you're solving inequalities, it's similar to solving equations. So below are some explanations about multiplying and dividing by positive numbers, some rules for that. When you're multiplying by positive numbers, working with an inequality, the statement is going to be true and the inequality symbol stays. You don't flip the inequality. And when you're dividing with inequalities, you're going to divide on the same side, like you would solving an equation, to make the statement true. And again, when you're dividing, the inequality symbol would stay the same. So when I go on to this next slide, I'm going to talk a little bit about when you're dividing or multiplying inequalities by negative numbers. When you multiply or divide both sides of an inequality by a negative number, you must reverse the inequality symbol to make the situation true. So again, I'll emphasize multiplying or dividing an inequality by a negative number, you're going to reverse the inequality. So let's do some examples so you can see what I'm talking about. The first few examples, we're just working with multiplying and dividing by positive numbers. So here we're going to solve the inequality and graph the solution. Looking at example number 1, we have 7x is greater than negative 42. So I need to get x by itself. I need to isolate x, so I need to take the inverse operation of 7x. So the inverse operation would be dividing 7 to both the left and the right side. So on the left side I will have x. The inequality sign stays as a greater than symbol. Negative 42 divided by 7 is going to give me negative 6. So I have solved for this inequality. Now I'm going to graph my number line. This is saying x is greater than negative 6. Remember, when it's greater than, x is going to be going to the right. So I'll have so it's going to be an open circle at negative 6. X is greater than, so my variable x is going to be everything shaded to the right. I can label that x. Solving for the next example, we have 2.4 is less than or equal to m over 3. So when I'll rewrite it, so we have 2.4, so it looks more like a fraction, is less than or equal to m over 3. So here we have m over 3. We need to get m by itself. So the opposite of dividing here is we're going to multiply. We're going to multiply the right side and the left side by 3. These 3's cancel on the right side, so I'm just left with m on the right. 3 times 2.4 is going to give me 7.2. So what I have here for when I solve this inequality is 7.2 is less than or equal to m. So now I need to graph this. So 7.2, here it is. I can label that 7.2. It's going to be a closed circle because it's including that. So 7.2 is less than or equal to m, or think about what I said in class today. When you look at where the variable is placed and how that symbol is facing the variable, so this is also saying m is greater than or equal to 7.2, so if it's greater than, it's going to be shading to the right. So that was multiplying and dividing by positive numbers. Again, notice my sign stayed the same. Let's go on to the next slide so I can show you how we multiply and divide by negative number. So here, for example number 3, we have negative 12 times x is greater than 84. I'm going to isolate x, get it by itself, so I'm going to divide the left side by negative 12, divide the right side by negative 12. So since we're dividing by a negative, we're going to flip the inequality sign. So we're going to now have x, we're going to flip that to become less than 84 divided by 12 is going to give me -7. So is x less than -7? That's going to make that statement true, because -12 times -7 is going to give me a value that would be greater than 84. Let's graph this. So I'm going to have an open circle at -7. X is less than -7, so I'm going to be shading to the left. The next example, we have -8 is less than or equal to x over -3. We want to get x by itself. We're now multiplying both sides by negative value. To make this inequality true, we're multiplying by negative, so we will have to flip the inequality sign. These -3's cancel, so on the right I have x. I'm going to have to switch the sign, so it's less than or equal to. I'm going to make it greater than or equal to. -3 times -8 is 24. Draw a number line. So 24 is greater than or equal to x. I will have a shaded in circle at 24. Another way to look at this is x is less than or equal to 24, so I'm going to shade to the left. And these are our notes for lesson 3.3.